In stage 5, we're going to add persistent storage to our pod and therefore our container workload. We're going to do this by using a flex volume driver, and this is going to allow us to create a storage volume. The flex volume driver that we're going to use is an open source bridge between Kubernetes and the Docker volume plugin, and it's called Dory. Full disclosure, Dory is a project that I originally initiated and open sourced as part of HPE storage. Dory provides both a flex volume driver and a provisioner. We're going to concentrate on the flex volume driver today. Policy-based management of storage in Kubernetes is an exciting topic, but we'll cover that in a later episode. Let's take a look at what we have to change in our pod definition to effect this. Just like last time, we will compare this with our previous one. We went from 4 to 5 in the name, and then the really interesting stuff is right here. You can see that we've created a new volume here called MySQL Persistent Storage. It's using the Flex Volume plugin, and the driver in this case is hpe.com Nimble for Nimble storage. This is the fully supported version of that Dory plugin for Nimble storage. What Dory allows us to do is specify the options that are available in a Docker volume create as options to the Flex Volume plugin. What I'm doing here is saying I want a 30 gig volume. I want it to be deduplicated. The name I'm going to give it is example storage volume. The description is going to say something about my database. The performance policy I'm going to select is SQL Server. I want to protect this volume with a volume collection that uses this protection template as its base. I want to make sure that it's thin provisioned, and I'm going to use a conflict delay of 30 seconds. This 30 seconds we should make sure matches this termination grace period 30 seconds here. So if you're expecting the grace period to take longer than 30 seconds, say you set this to 60, then you should set this to 60 as well. So these two make sure that your application shuts down cleanly, syncs all the data to disk before the next pod is able to start and have access to this volume. I should point out that this is just a subset of the options that are available from the Nimble driver. I've just chosen a few here as an example. What we'll do before we create this pod and therefore the volume, we'll take a look at the storage system to show that that volume does not exist yet. Here we see that we do have some volumes, but none are named example storage volume. So we've created our database. See that we have it running here, and what we'll do is, before we jump into it, let's go back to that storage screen and refresh this. We can see now we've got our example storage. Let's jump into the pod. And if we do our show databases, we have our info database, so we can create our table. And then I'm going to insert our data. And then we'll just select that information. And sure enough, we've got our rows of data. Now, what I did last time was sneak in behind the scenes and stop the Docker containers. And of course, we lost all the data when Kubernetes restarted this pod for us. So I'm going to do the same thing here. Switch over to my SSH session. Make this a little bit bigger. And we've got our 2 containers started a few minutes ago. So we're just going to do a Docker stop on this guy and this guy. And if we switch back over to our Kubernetes view and we do get pod, we'll see now we have 1 restart. And let's jump back into the pod. Alright, so we still have our database. That's good. But that's going to automatically get created because of the environmental variable that we set. Let's see if we use info, and then we select star from, what do we call it, team. So our data is preserved. So I've showed killing the containers behind Kubernetes back and the fact that Kubernetes will restart those and our data this time is maintained, of course, because we're using a volume. The other thing is that now I can delete the pod, and when it's created again it will still have the data because we still have this reference to our persistent volume in our pod. Alright, so we've got our 1 pod here. We can do a Now it says that the pod is deleted, but it's very likely still in the process of cleaning the pod up. Oh, good, it's gone. Okay, so let's go over and refresh our view here. Make sure that our volume didn't get deleted with the pod, which it should not. Yep, still there. See that we've increased the size of the volume a little bit with our massive table. And now we should be able to recreate it. Now, I've recreated it with the same YAML file without changing anything, right? But this is how you might change the version. So if you were going to upgrade SQL, maybe change the image or change the name. Perhaps you wanted to add some different labels or modify labels. So you can modify the pod or you can delete the pod and recreate it. In either case, your data is preserved because your data is outside of the pod sitting in the volume. Oh, that was a name. From team. There we go. Okay, so what I did there was, please excuse the typing error, what I did there was jump back into our pod, and this new pod in fact has the same data as our last pod. I'd just like to reiterate that what we've covered here are the absolute basics. I'm not suggesting anyone run a database in Kubernetes simply using a pod definition. What this is meant to do is introduce you to some of the concepts. Obviously, using a storage volume is one option. In the future, we're going to talk about using a provisioner, which allows us to specify things in storage classes and give end users the ability to create storage on their own. Thanks for hanging in there through all of the videos. Hopefully you found this educational, if not entertaining.